Hello everyone, this is Ankit from Kailasha Foundation Fun and Learn portal, and this is your next lecture of Algebra. This is actually lecture 4, and in this lecture we are going to discuss factor theorem and remainder theorem. That is a very important concept of algebra. So at first we are going to discuss remainder theorem, that what happens when we divide a polynomial function. Yes, I can use that term now as I have taught you what is a function. If we divide a polynomial function by another polynomial function of smaller degree, okay, for example, x cube plus x square plus 4 is divided by x plus 1. Okay, x cube plus x square plus 4 is divided by x plus 1. What happens? What remainder do we get? We have to figure out. Okay, so x cube plus x square plus 1 divided by x plus 1, x cube, so x square will be there, x cube plus x square, oh sorry, it was 4. Okay, x cube plus x square is there, subtracted, cancelled out, 4 remains, so 4 is remainder, x square is the quotient. But how do we conclude to this result without the actual division process, which seems difficult to very large number of students. Okay, so we have to figure out a way to come to this result without the actual division process, that the remainder is 4. Say fx is equal to x cube plus x square plus 4 is that polynomial function which is to be divided, that means dividend function, dividend polynomial function. Okay, and now divisor is linear divisor. Okay, this works for linear divisor. Linear divisor is x plus 1. Now 0 of first step 1, 0 of the linear divisor, 0 of a divisor or 0 of a polynomial means, 0 of a polynomial means put that equal to 0 and get its value. Sorry, put this equal to 0, so x will be minus 1. So minus 1 is the 0 of the polynomial, minus 1 is the 0 of this divisor. Okay, that means if we put minus 1 in place of x, we get 0. So 0 of this is minus 1. Now step 2, put the 0 in the main function, put the 0 in the main function. That means this step 2 is the last step. Actually the remainder is obtained directly when we put this one in place of this x. So it is when it was x, it is x cube x square, so now it will become minus 1 cube plus minus 1 square plus 4. Okay, so that is minus 1, sorry, uh, minus 1 plus 1 plus 4. Okay, so it is 4. The divisor is, sorry, the remainder is 4. Okay, let us take a look at a few more examples. Now see, this question is there, we have to divide by this. Okay, x plus 5, so 0 is minus 5 and fx is x cube plus 4x square minus 5x plus 3. Now when we put minus 5 there, so remainder we get directly, remainder is equal to f minus 5 is equal to minus 5 cube plus 4 into minus 5 square minus 5 into minus 5 plus 3 minus 125 plus 25 fours are 100 plus 25 plus 3. This is cancelled out, but 3 remains is not equal to 0. Okay. Remainder is not equal to 0 means not divisible. Means this is not a factor of this. What you have learned so far is the remainder theorem. Is the remainder theorem that the zero of a divisor is a, so fa is the remainder. Zero of the divisor is a, so fa is the remainder. For example, if the theorem is basically remainder theorem. Let me write here remainder theorem. If we divide fx by x minus a, if we divide fx by x minus a, then 0 of this is a. Okay, then remainder barabar remainder is equal to f, sorry, fa. Okay, this is the remainder theorem. And what if we don't get the remainder? What if the remainder is 0? What if the remainder is 0? That means that is completely divisible. Completely divisible means x minus a is a factor of fx. So factor theorem is what? Factor theorem is an extension of remainder theorem. Factor theorem is if fa is equal to 0, then fx is, sorry, x minus a is a multiple, a factor of fx. Okay, if fa is equal to 0, then x minus a is a factor of fx. This is the factor theorem. Okay, now how do these theorems help us? First, to determine the factor or to figure out the remainders. Okay, next is factor theorem. Factor theorem helps us in factorizing higher degree equations. For example, fx is equal to x cube plus 6x square minus 19x plus minus 24 is equal to 0. Oh, sorry, this is fx. Okay, this is fx is not equal to 0. That was a mistake. Okay, now by hit and trial we try to put uh, minus 2 minus 1 1 2 etc in place of x here. And by hit and trial, when we put 1 here, we get 1 plus 6 into 1 square, that is 6, minus 19 into 1, that is minus 19, then minus 24. It is not equal to 0, but when we put minus 1, then minus 1 cube, that is minus 1 plus 6 times minus 1 square, that is 6, minus 19 into minus 1, that is plus 19, minus 24. So 25 minus 25, that is 0. So this is 0. That means x minus minus 1 is a factor. That means x plus 1 is a factor of fx. Now we are able to divide fx by this x plus 1. So x cube plus 6x square minus 19x minus 24. We are going to divide it by x plus 1. X square is first of all there, x cube plus x square, 5x square minus 19x minus 24. Now looking at this, we put 5x here. Now 5x square plus 5x minus 24x minus 24 minus 24 minus 24x minus 24 cancelled out. So this into this, x plus 1 x square plus 5x minus 24. Now this is quadratic. We can factorize it by middle term splitting or any other method we know, or with whatever method we are comfortable with. Okay, so we get 8 and minus 3 as the middle term splitting results. So x plus 1 and x plus 8 x minus 3. These are the three factors we got by factorizing this dividend. Okay, x plus 1 x plus 8 times x minus 3. Now if we put equal to 0, or we have to construct the graph of this equation, cubic equation, minus 19x minus 24 equal to 0. If we have to draw the graph of this equation, that means this equal to 0, then we have 3 points of intersection. Those are minus 1, minus 8 and plus 3. Okay, now we will try to put a value just less than minus 1 or just higher than 3. Okay, now we will try to put a value, in fact, if we arrange these in ascending order, we get minus 8, then minus 1, then 3. So a value just less than minus 8 or just higher than 3. Okay, uh, less than minus 8 will be difficult to put, so we put plus 4 here. It is 64 plus 6 into 16, that is 96, minus 76 minus 24. It is positive. So what we got is 3 minus 1 minus 8. Beyond 3 it is positive, so it was coming like this, it crossed it like this, and then this. So this is the shape of the graph of this equation. See how many things we did at the same time using this factor theorem and remainder theorem only. So factor theorem and remainder theorem is that much useful, and you must be comfortable with these theorems. So anytime if you have to find the remainder of uh, a division, say x square minus 5x plus 7 being divided by x minus 2. Now the 0 of the divisor is 2, just put 2 here. So 2 square minus 5 into 2 plus 7, that is 4 plus 7, 11 minus 10, that is 1. So you get remainder 1. That is the simple concept behind this. Factor theorem and remainder theorem is basically the remainder you get when you divide fx by x plus a, fx by x minus a. the remainder you get when you divide fx by x minus a is fa. Okay, this is the remainder. The remainder you get when you divide fx by x minus a, you get is fa. Okay, as simple as that. And if fa equal to 0, then that is the factor of that fx. It is common sense. So both these theorems are same. In fact, factor theorem is extension of remainder theorem, and both of these are useful, very very useful. Okay, now this lecture was a small lecture, and I am going to conclude this lecture at this point only. Okay, so thanks for watching this video. Don't forget to like, share and subscribe. Happy learning. Bye bye. Good night.